In this lesson, we're going to talk about polygons and the coordinate plane. Essentially, we're going to connect algebra and geometry through coordinates. We're just going to look at examples. The first one, graph ABC given A is 1, 6, B is 3, 1, and C is 8, 3. What formula can we use to find AB? I want to find how long AB is. And BC. Let's also do BC. Well, for that, we're going to use the distance formula. So if you remember the distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared. If we're going to do AB, our point there is 1, 6, B is 3, 1, and C is 8, 3. Let's substitute it in. This is x1, y1, x2, y2. So I'm going to do 3 minus 1 squared plus 1 minus 6 squared. Based on the way I have it written. x1, y1, x2, y2, 3 minus 1, and then 1 minus 6 squared. I'm going to get 3 minus 1 is 2 squared. 1 minus 6 is negative 5 squared. Now we do squares, the negative goes away. So we 4 plus negative 5 squared is 25. Because again, once you square a negative, it makes it positive. We just have this, and that's square root of 29. Okay, let's find the distance of BC. The same idea. So BC is going to be the same formula. We're going to do 3 minus 8 squared plus y2 minus y1, 1 minus 3 squared. Again, it doesn't matter which one's x1, y1 because you're squaring it anyway. It doesn't matter. Now I get negative 5 squared plus negative 2 squared. Again, you square it, the negative goes away. We're just going to get 25 plus 4, the square root of 29. We know that AB is congruent to BC. They're the same length. What point bisects AB? Like, what's the middle point of AB? To do that, we're going to use the midpoint formula. Remember, the midpoint formula is just find the average, basically. You can do x1 plus x2 divided by 2, y1 plus y2 divided by 2. Like that. We're trying to find the midpoint of AB. x1, y1 is 1 and 6. That's 1 and that's 6. And then x2, y2 is 3 and 1. So that's 3 and that's 1. We get 1 plus 3 is 4 over 2. 6 plus 1 is 7 over 2. So we get 2 and say 3.5. So that's my midpoint. Next, how can you show that angle ABC is 90 degrees? And we want to show that ABC is a 90 degree angle. There's a couple ways. One way is that we know this is already square root of 29, and this is square root of 29. One thing we could do is to try to see if a squared plus b squared equals c squared. Pythagorean theorem, see if it holds. If it does, this is the right angle. If it doesn't, it's not. Now to do that, I would have to find the distance between AC and do the whole formula. An easier way of doing that is find the slopes of these guys. If I find the slope of AB, the slope of BC, and if they're negative reciprocals of each other, then they're perpendicular. So that's been the easier way of doing it. So we're going to do it that way. Let's find the slope of AB, and let's find the slope of BC. Now, a couple ways to do it. I'm going to do one for each. For AB, I'm just going to do rise over run. Remember the way rise over run works? You pick 2 points, like that one, and another one that crosses nicely. I think this one. We do that. This is down 1, 2, 3, 4, 5, and then right 2. Minus 5 and over 2. My slope here is going to be, m is going to equal negative 5 over 2. Rise over run. The change of y over the change of x. Like that. And since we went down, it's a negative, we went right 2. The slope of BC, let's do this using the formula. If I want to find the slope, I'm going to do y2 minus y1 over x2 minus x1. You can do either way works. y2 is 1 minus y1, which is 3, and then we have x2 is 3 minus x1, which is 8. And I get negative 2 over negative 5. 2 negatives make a positive, I get 2 over 5. Our slopes are negative 5 over 2 and 2 over 5. Those are negative reciprocals of each other. If I flip it and change the sign, then they match. So these are perpendicular. AB is perpendicular to BC. It is 90 degrees. Classify the triangle above. With everything we know, I know that these are the same. It's isosceles, and I know it's a right triangle now. So this is an isosceles right triangle. We're putting everything together. We know it's isosceles because the two sides are the same, and we know it's a right triangle because of the slopes. That's the idea. Let's do another one. So I want to classify this triangle based on the information I have. Is the triangle equilateral, isosceles, or scalene? To do that, I got to find the measurements of all the sides. We're going to do a lot of distance formula today, it looks like. So x is 1, 2, y is 5, 8, and z is 8, 6. Let's do xy first. The distance formula of xy. So we'll say this is x2. I'm going to do 5 minus 1 squared, 8 minus 2 squared. 5 minus 1 squared plus 8 minus 2 squared. We're going to get 4 squared plus 6 squared, which is 16 plus 36, which is 52. Okay, the square root of x, the distance of xy is square root of 52. Right, and then we're going to do the same thing for yz. I'm just going to use the formula real quick. 2, 1, I'm going to do 8 minus 5, and then 6 minus 8. So 8 minus 5 is 3 squared. 6 minus 8 is negative 2 squared. 9 plus 4, so square root of 13. That's square root of 13. And then this side, let's do xz. So let's say this is y2, x2, y2, x1, y1. 8 minus 1 is 7. And then same thing with y. 6 minus 2 is 4. I get 49 plus 16, and that is 66. Square root of 66. They are all different sizes. So this is scaling. If we had two sides the same, it would be isosceles. If we have all three sides, it's equilateral. They're all different with scaling. Next, is it a right triangle? So in this case, since I actually have all three sides, I'm just gonna do this. Does a squared plus b squared equals c squared? Now, if we're looking at this, the c, remember c has to be the biggest side. C has to be the hypotenuse. In that case, it has to be this guy. That'll be my c. So let's see if this holds. So we're gonna do square root of 52 squared plus square root of 13 squared. And does that equal square root of 66 squared? Now, looking for us, these cancel out. Let's get 52 plus 13. Does that equal 66? And I would get 65. No, not right. It's not a right triangle. Again, that's one way to do it. Other way to do it, we could have gone back and done our XYZ. We could have gone back and done the slopes of these guys. Like the slope of this one, pick 2 points, rise over run. This looks like 4 and 2. So my m here is 2. Pick the slope of this guy, rise over run. From here to there, my slope is negative 2/3. They are not negative reciprocal to each other. It also doesn't work that way. So either way it works. One last one. Given this 4-sided figure here, R is 1,5, S is 2,8. I gotta write these down. 1,5, S is 2,8, T is 8,4, and U is 7,1. What type of parallelogram is RSTU? What's a parallelogram? Is it a rhombus, a rectangle, square, or none of these? Well, it's not a square. It's not a rhombus. This is not a square. It's not a rhombus. Because rhombuses have all sides the same and squares have all sides the same. It might be a rectangle. To check that. So let's go about doing it. So the easiest way to check that is check the slopes. We're just going to find the slopes of all these. Let's find the slope of RS first. We're just going to do rise over run. So over 1, up 3. My slope here is going to be 3 over 1. Now let's do RU. I'm going to go down 1, 2, 3, 4. I'm going to go over 1, 2, 3, 4, 5, 6. My slope here is negative 4 over 6. You can reduce that and get negative 2 over 3. If I reduce, I just divided both top and bottom by 2. But look at these two. They are not perpendicular. 3, negative 2/3. So it's not a rectangle. It's not a rhombus. It's not a square. So it's none of these. It might just be a parallelogram. Let's double check it's a parallelogram. Let's find the slope of these two and show if they match. So let's do TU now on the slope. That's this one and this one. So over 1, up 3. So slope is 3 over 1. Hey, these match. These guys are parallel. And then let's do S. We haven't done S to T yet. Again, rise over run. So I'm going to go across to make it easier. 1, 2, 3, 4, 5, 6. And then we're going to go down 1, 2, 3, 4. Again, it is rise over run. You got to put the up and down the Y on top. The negative 4 over 6, which again reduces to negative 2/3. So these are parallel and these are parallel. So it's definitely a parallelogram. But it's not a square because these are not the same size. I mean, we could do distance formula, but by looking at it, it's not a rhombus, same problem. It's not a rectangle because these don't make a 90-degree angle. It must just be a parallelogram. Is it a rhombus? No. Not all sides the same. Same length. Is it a square? No. No right angles. Not all sides same. And it's not a rectangle. No. No right angles. Okay, let's look at one more, actually. It's real quick. Let's talk about trapezoids, kites, and the coordinate plane. The same idea, but with the trapezoid and kite. We're just going to do this trapezoid here. And the first question, is it a trapezoid, actually? I got to show it's a trapezoid. Remember, trapezoids are one set of parallel sides. I got to show that this side is parallel to this side. Right? If I can show those two sides are parallel, then it's a trapezoid. That's all I got to do. Let's find the slopes of these guys. I'm going to do 80 first. My slope, we're going to do rise over run. Slope's going to be over 2 and up 1. So slope is 1 over 2. Now let's find the slope of BC. The same idea. We're going to do rise over run. Now again, if you want, you could go like right here. It crosses perfectly right there. We're just going to go to this point to make it a little faster. 2 over 1. They are parallel. It's a trapezoid. Now, if they want to, we can figure out if it's isosceles trapezoid. I can find the distance between these guys, but it doesn't look isosceles. Anyway, that's the lesson.